Our topic of discussion today is 2 and 3-dimensional trigonometry. So we'll start by investigating how can we use our sine rule, followed by our cos rule, and finally our area rule. Once we have completed that, we will then move on to a few past paper questions. So let us start. When we are dealing with our sine rule, it's important to know what your sine rule looks like. So this can be found at the back of your question paper. So your sine rule is sine of angle A over side A is equal to sine of angle B over side B, which is finally equal to sine of angle C over side C. So the lowercase letters represent the sides, whereas the uppercase letters with the angle symbol on top of them represent the angle itself. Now this can also be represented in a different notation. You don't have to have sine on top and the side at the bottom. You can have it swapped or interchanged. So an alternative representation is our side A over sine of angle A, which is equal to our side B over sine of angle B, which is equal to side C over sine of angle C. But for this particular case, I am going to stick to the first notation. So let us investigate how can we use that rule or that formula in an actual question. So we have this triangle. Let us label this angle A, angle B, and angle C. Let us give angle A an angle of 25 degrees. Let us give side BC, which can also be represented as side A. How we find the lowercase a, b, and c, which is the sides, is we look at the angle and we look at the side opposite that angle. If it's an uppercase A as the angle, the side opposite that angle A would be a lowercase a. Or you can just refer to it as BC, both is acceptable. So this is then going to be our side A equals to 10 centimeters. Let us give side B a length of 5 centimeters. So this is side B. And we can leave C and side C unknown. Our question is to now find the angle B. So if we need to find the angle B, we then need another angle and two sides in order to make use of our formula. Because in order to use your sine formula, you need two angles and two sides. And one of those variables have to be unknown. In this particular case, one of our angles is unknown, which means that we need two sides and an angle. So we are going to use sine of angle A over A is equal to sine of angle B over B. Now we're going to substitute what is the side B and what is the side A. So if we look closely, our side A is BC, so we can substitute that as BC. We then need to find out what is the side B. So if we look at B, that side is AC. Now we can then go and substitute the known values into our formula. So let us now go and investigate what is actually known. So we have an angle of 25 degrees. That is our angle A. We then have an angle B, which is what we are trying to calculate. That is unknown, so we're not going to substitute for that. We know that BC is given as 10 centimeters, whereas angle A, or rather side AC, is given as 5 centimeters. So we now have 3 items that we can now go and substitute into our formula in order for us to solve for angle B. So we have sine of 25 degrees over 10 centimeters is equal to sine of angle B over 5 centimeters. We can now go and cross multiply. So we'll multiply the 5 with sine 25 degrees, and we will multiply the 10 with sine of angle B. From this point, we now need to try to isolate B. So because sine is attached to B, we are not going to divide by 10 sine because the sine is attached to B. We are only going to divide by 10 on both sides. So this is then going to be 5 sine of 25 degrees over 10 is equal to sine of angle B. Now, because we've isolated sine B, there's no coefficient greater than 1 in front of sine B. It's just a coefficient of 1. We got rid of everything else. We can now go and move sine to the other side, making it sine inverse. If you want to put sine inverse on your calculator, all you have to do is press shift, then press sine. It's going to look like a sine with a -1 and a bracket will open up. So that is then going to be angle B is equal to sine inverse of 5 over 10 is going to be 1 over 2. So that is going to be sine 25 degrees over 2. And we can now put this into our calculator. So sine inverse of sine 25, close the bracket, all over 2, and then we can close the bracket again, and that is going to give us our angle B as 12,20 degrees. Now that is our angle B. So we've now used our sine rule in order to calculate the angle B. Something important to take note of is that whenever we are dealing with our sine rule, and you'll see the same thing will apply to the cos rule, we always look at a angle and the side opposite that angle. We need to now try and build relationships, or we need to try and keep them as pairs, the angle and the side opposite that angle. So let us now move on to our cosine rule. Now, our cosine rule makes use of the formula A squared equals B squared plus C squared minus 2BC cos of angle A. Now, something important to take note of is that the side that we are calculating is going to match the angle that we are going to use. So you'll see that when we actually do an example. So let's label this A, B, and C. Let's give this an angle of 30 degrees. Let's give AB a length of 10 centimeters and AC a length of 15 centimeters. Now, our question is to calculate the length BC. Now, where do we start with such a question? And another thing that can pop up is what is represented by B and what is represented by C, or what does B and C represent? So let's try and find that out. So first of all, The lowercase b and c represents sides, not angles, okay? That is important to take note of. So when we start with our question, we need to determine the length BC. So like I mentioned earlier, if we are finding the side A, we're going to use the angle A. So if we are finding the side BC, which angle do we now use? So how we find that is we are going to draw an arrow to the angle across BC. That is the angle that we are now going to use. In order for us to find BC, we are going to use the angle opposite BC, which is our angle A of 30 degrees. Now, how do we figure out which sides we are going to use in place of B and C? Because those are important. We need to know what to substitute. So in order to find that, all you now need to do is draw an arc around the angle that you are going to use. So we're going to draw an arc around the 30-degree angle. Once you've drawn your arc, you can now put in arrows at the ends of that arc. The arrows are going to point to the sides that you are going to use. So in this particular case, we've drawn an arc around the 30-degree angle, and the arrows are pointing to sides AB and AC. So we need to use the sides that are next to, or another way of putting it, the sides that are adjacent to our angle that we are going to use. So let us put in our formula. So our A, our lowercase a, is representing the side that we are looking for, which is BC. Next, we need to put in our lowercase b and our lowercase c, our side B, side C. Now we've already determined that our sides that we are going to use for B and C are AB and AC, minus 2 times AB times AC times cos of our angle A. So that is important. If you're finding the side BC, you use the angle that is opposite BC, in this particular case, angle A of 30 degrees. Now we can start to substitute. So we're going to substitute in place of AB, which is 10, don't forget to square that, plus AC, which is 15, don't forget to square that, minus 2 times AB of 10 times AC of 15 times cos of our angle 30 degrees. From there, we can now put the entire right-hand side onto our calculator. So 10 squared plus 15 squared minus 2 times 10 times 15 times cos of 30 degrees. Now that is going to give us a value of 65.19. So we've put the entire right-hand side onto our calculator, and we've now obtained a value of 69, or rather 65.19. From here, we now need to get rid of the squared on top of BC. Now, something important to take note of is how do we actually get rid of a squared on top of a variable? So if we have x squared, how do we get rid of that squared? We use the opposite operation, which is square root. So our square root will cancel the squared, and we will then be left with x. The opposite also works. So if we have the square root of x and we want to get rid of that square root, all you now need to do is square that variable and its root. So you'll square this so that the square root will cancel the squared, and you will then be left with x. So we're going to apply the exact same concept here. So we're going to try to get rid of the squared by square rooting both sides. We are using the same thing on both sides. We're square rooting the left and we're square rooting the right, because you cannot only square root one side. Whatever you do to the left, you have to do to the right. So if we square root BC squared, we'll end up with BC. If we were to square root 65.19, we would end up with 8,07. And keep in mind, our unit of measurement is centimeters. So we have now found the length BC as 8.07 centimeters. Let us now move on to our area rule. Our area rule is area is equal to a half BC sine of angle A. So let us take a step back and have a look at the area rule that we are used to, or the area rule that we have been using in our previous grades. Now that area rule is area is equal to a half times base times height. Now this rule is the exact same rule that we are now using. The only difference is previously we worked with right-angled triangles. So our angle was 90 degrees. Therefore, we were then able to exclude the angle part because sine of 90 is just 1. So we were able to exclude that. Now, moving forward, we might not always have a 90-degree triangle, or we might not always know the height. So we now have to use the full formula, where we have to incorporate the angle of that triangle into our formula. So let's take a step back and calculate the area of this triangle using our older formula, whereby we multiply a half times the base times the height, and then we'll use our newer formula whereby we have area is equal to a half times 2 sides times sine of the angle. And we'll see if we get the same value or if we get a different value. So let's have this as A, B, and C. Let us give this a value of 10 centimeters and this a value of 5 centimeters. Now, let us use our area rule from our previous grades. We need to identify which is the base and which is the height. So our base is going to be BC and our height is going to be the side that is perpendicular to BC, which is our base. Now, if you notice, the side AB meets BC at a 90-degree angle, which means AB is perpendicular to BC. Therefore, our height is going to be AB. So we have area is equal to a half times our base, which is BC, times our height, which is AB. So we can then substitute. So we have BC as 5 centimeters and AB as 10 centimeters. Now, from here, we can put this into our calculator. So we'll have a half times 5 times 10, and that will give us 25 centimeters squared. So that is the area. Let us now see if we can get the exact same area value if we were to use our formula area equals a half BC sine of A. So we'll move that to the side. Let us split that a bit. Okay, so our formula is area equals a half BC times sine of A. Now, something important, we have to figure out which is side B and which is side C. So we're going to use something similar to what we used in our cosine rule, whereby we are going to use the sides adjacent or the sides next to our angle. So because we are using the angle of 90 degrees, we are going to draw an arc at 90 degrees. And then we draw our arrows. And the sides that the arrows are pointing to are going to be the sides that we are going to use. So in this particular case, our angle is going to be 90 degrees, which is angle B. And our sides that we are going to make use of are AB and BC. So I'll repeat how we figure out which sides we are going to use one more time. We draw an arc at the angle we are going to use. We draw arrows at the end of that arc. Those arrows will then point to the sides that we are going to use. Alternatively, you can just identify the angle and identify the sides that are next to or adjacent or on the left and the right of that particular angle. So I'm going to rewrite my formula so that it matches the triangle we are using. So area will be equal to a half times AB times BC times sine of angle B. So I'll erase this top formula over here and move this slightly to the top so that we can get some space. So let us now substitute. So we've got a half times 5 centimeters times 10 centimeters times sine of 90 degrees. Now we can put this into our calculator. So we'll put a half times 5 times 10 times sine of 90, and we will end up with the exact same answer as we did before. Let us now have a look at our area formula, whereby the triangle we are going to use is not a 90-degree triangle. So let us move this slightly up. So we'll have this as A, B, and C. Let us give this an angle of 40 degrees. Let us give this side AB 10 centimeters and our side BC as 15 centimeters. We can also include sine AC if we want to, but I'm not really going to do that, as I know all we need is an angle and the two sides adjacent to that angle. So let us find our area. So our area formula is going to be area equals a half times. Now we need to figure out which sides are we going to use. So we draw an arc around our angle, and we draw arrows at the end of that arc. The arrows are going to point to the sides that we are now going to use. So we are going to use side AB and side BC because those are the sides that our arrows are pointing to. So AB times BC times sine of angle B, which is our 40-degree angle. From there, we are going to substitute. So AB is 10 centimeters and BC is 15 centimeters. And we have sine of 40 degrees. From there, we can put this entire thing into our calculator. So a half times 10 times 15 times sine of 40 degrees, and that is going to give us an area of 48,21 centimeters squared. So that is our area for that particular triangle. Let us now move on to our past paper questions. So our first past paper question is from a November 2018 exam. So we have question 7. A pilot is flying in a helicopter at point A, which is h meters directly above point D on the ground. He notices a strange object at point B. So let us stop there. Let us look at our diagram. So from our diagram, we can see that our pilot is directly above point D. And then he notices a strange object at point B. So let's just make a note of that. Point B is where our strange object is. And something important to take note of, if the helicopter is directly above point D, think of it as a pole or a wall. A wall is always going to be straight up. So this guy or this helicopter is straight up from the point D, meaning that it has to be 90 degrees to the ground. That is why you can see we have those 90-degree symbols. The pilot determines that the angle of depreciation from A to B is 30 degrees. Now, something important to take note of is that when you are dealing with angles, the angles will, in most cases, start at the horizontal. You can think of the horizontal as the ground or the reference point or the x-axis. Now, always remember that this x-axis is going to be parallel to the ground, okay? So an angle of inclination would go up, whereas an angle of depreciation will go down. It doesn't matter which side you start, inclination going up, depreciation going down. So whether you start from the left or the right, if it's inclined or if it's an angle of inclination, it's going to go up. If it's an angle of depreciation, it's going to go down. So think of inclination, you're moving up, incline upwards, depreciation when you're feeling depressed, when you're feeling down, so the angle is going to move down. Now, there's an angle of depreciation of 30 degrees, so that is this angle over here, it's 30 degrees. He also determines that the control room at point C is 3h meters from A. So the distance from A to C is 3h. So our value, or rather our side AC is 3h, and our side AD is h meters. And this is our control room at point C. And BAC is 2x. So our angle BAC, which is this angle over here. So if we were using triangle ABC, one of the angles or one of the known angles would be this angle over here, 2x. Point C, B, and D are the same horizontal plane. So in order for you to be on the same horizontal plane, it means it needs to be flat or leveled. So that means that the points B, D, and C could be on the ground. Those points B, C, and D all have the same height above the ground or are all at the same level. So let us assume that that gray shaded area is the ground. Maybe it's some grass or tar or road or whatever it is. It's the ground. B, D, and C are all on the ground. The scenario is shown in the diagram below. So we have question 7.1, determine the distance AB in terms of h. So what does it mean to find the length AB in terms of h? It means that whatever our distance of AB is going to be, it needs to have h in it. So for example, if we find an answer as, let's say, 10 meters, that is going to be incorrect because it does not have h in it. However, if we find a value of AB as, let's say, 5h or 10h, that might be correct because it has h in it. It is a value for AB in terms of h. Whenever they say in terms of something, it means that variable needs to be within your answer. So if they said in terms of x or in terms of y, that variable x or y or h or whatever the variable is needs to be within your answer. Your answer needs to be in terms of that variable. So we now need to find or determine the distance AB in terms of h. So let us now draw that triangle. So that is our 30-degree triangle, and we've got A on top, which is where our helicopter is. We've got D on the ground, which is directly below our helicopter, and we've got B at the corner on the left, which is where our strange object is. Now, something important to take note of is our angle of depreciation. So let us now put in our angle of depreciation. How are we now going to do that? So keep in mind what I mentioned earlier. An angle always starts, or not always, but in most cases, an angle of inclination or depreciation will start from the horizontal. And that horizontal is parallel to the ground. So that is now our horizontal, and that horizontal is parallel to our ground. Our ground is BD, and there is an angle of depreciation of 30 degrees. So something important that you should notice is the Z shape that is formed. That Z shape that is formed implies alternative angles. So we now know that that angle of depreciation is also the angle of B. So that means our angle B is 30 degrees. So angle B is 30 degrees, reason being alternative angles. Now, how are we going to find the length AD in terms of B? Before we even start with our question, let us go and put in one more value that I actually forgot to put. That is the length AD. Now, from our question or from our diagram, it is mentioned that AD is h meters. So we now need to find the angle, or rather the side AD in terms of h. So let's have a look at our options. Can we use the sine rule? Yes, we can, because we have two angles and one side, and we are trying to find the second side. So we can use our sine rule. So we can use the 30-degree angle of B and the side opposite that, which is h. We can then use our 90-degree angle and the side opposite that, which is AB, which is what we are trying to calculate. Can we use our cos rule? No, we cannot, because we do not have two sides, or we do not know the value of the two sides adjacent to any of the angles. Can we use our sine, cos, or tan identities? Let us start with tan. Can we use tan? Tan of 30 degrees is equal to the opposite, which is h, over the adjacent, which is BD. That will not work because we do not have the adjacent value. Let us have a look at cos. If we were to use cos, that would be adjacent over hypotenuse. We do not have the adjacent value and we are looking for the hypotenuse, so we cannot use that side or that identity because we'd have two unknowns. Let us have a look at sine. So if we wanted to use sine, we can have sine of 30 degrees is equal to the opposite, which is h, over our hypotenuse, which is what we are looking for. So if we use sine, we're using h, we're using AB. We are looking for AB, we need AB in terms of h. So because h and AB are both within that equation or that identity, it is possible for us to use the sine identity. So let us use both methods. So on the right, we'll use our sine rule. On the left, we'll use our sine identity. It's basically going to be the same thing. The only difference is that when we use our sine rule, we're going to use sine of 90 degrees, which is 1. So it's basically the same thing. So let's start with our sine identity. So we have sine of 30 degrees is equal to the opposite, which is h, over the hypotenuse, which is our AB value. So let us replace hypotenuse with AB. That is what we are looking for. Next, we can cross multiply. So we know that this will be over 1. So we can cross multiply that 1 with h and AB with sine 30. And that is going to give us AB sine 30 equals h. From there, we can divide both sides by sine 30, and that is then going to be h over sine 30. Now, do not leave your answer like this. It is possible to simplify sine 30, so I would recommend that you simplify it and get a final answer. So how would we now simplify h over sine 30? If you notice, h has a coefficient of 1. Any variable that does not have a number in front of it or coefficient has an invisible 1. So on your calculator, you'll put 1 over sine 30, and that is going to give you 2. So that then means that we have 2h as our answer. That is the length. That is the length AB in terms of h. Now let us use our sine rule. So when we use our sine rule, we're going to use two angles and two sides. So I'm going to use the angle of 30 degrees and the side opposite that angle. So I'm going to use 30 degrees and h. So that is going to be sine of 30 degrees over h is equal to, now I need a second pair. So I'm going to use the 90-degree angle and my hypotenuse or my side AB, because that is what we are trying to find. From there, I can cross multiply. So I'll multiply h with sine 90 and AB with sine 30. That is going to give me AB sine 30 equals h sine of 90. Now from here, I can divide both sides by sine 30 in order to isolate AB. So I'll end up with h sine 90 over sine 30. And you can put this into your calculator, so you won't put the h, you'll just put sine 90 over sine 30, and that is going to give you a value of 2. So you therefore know that AB is equal to 2h. So you get the same answer irrespective of which method you use, because both methods are basically the same thing. The only difference is that here we include or we show sine 90, whereas in the first method we didn't show sine 90, because we know that sine 90 is just 1. So if we were to substitute 1 in place of sine 90 over here, it would look exactly like this, because h times 1 is just h. So it would then be h over sine 30. Let us now have a look at our next question, question 7.2. So our next question is question 7.2. Show that the distance between the strange object and point B. Show that the distance between the strange object at B and the control room at point C is given as BC is equal to h the square root of 25 minus 24 cos squared x. So we now need to try and find BC. What is BC equal to? So let us have a look at how we are going to do that. So if we look at side BC, we can see that that is the side on the ground between our strange object and our control room. Now, what triangle can we use that has BC in it? If you look at triangle ABC, we have the length AC, which is 3h. We've just calculated the length AB, which is 2h, and we need to calculate the length BC. So within that triangle, we now have two sides, and we have the angle in between those two sides, which is our angle A of 2x. So let us start by drawing our triangle, and then we can start putting in the values that we have and simplifying our formula such that it gives us what is in our question, which is BC equals h the square root of 25 minus 24 cos squared x. So we have ABC, so let us put that in. A on top, B on the left, and C. We were given that AC is 3h, AB was calculated as 2h, and the angle A is 2x. Let us confirm if that is correct. Yes, our angle A is in fact 2x. So let us now see what we are going to use to try and find the length BC. So if you notice, we're trying to find the side opposite the angle A. So we can use our cos rule. So let us put in our cos rule, which is going to be A squared equals B squared plus C squared minus 2BC cos of A. Now, what represents A, what represents B, and what represents C? So if we are trying to find the length BC, that is going to be our A. Now we need to figure out which is B and which is C. So in order to do that, we need to find the angle opposite our side that we are trying to calculate. So we're trying to calculate BC, therefore the angle opposite BC is going to be A, which is 2x. So that is going to be our angle A in our formula, 2x. Now in order to find B and C, which is the sides adjacent or the sides next to our angle 2x, all we need to do is draw an arc at the angle, put in the arrows, and whatever the arrows are pointing to, that is going to be the sides that we are going to use. So our arrows are pointing at AC and AB. So those are the sides that we are going to use in place of B and C in our formula. Alternatively, all you can do is just figure out which are the sides that are adjacent or which are the sides that are next to the angle if you don't want to use the arc method. So that is then going to be AB squared plus AC squared minus 2 times AB times AC times cos of angle A. So we can get rid of the top formula. From here, all we need to do is substitute. So BC remains unknown. AB is 2h all squared plus AC, which is 3h all squared, minus 2 times AB, which is 2h, AC, which is 3h, cos of our angle. Now keep in mind our angle is 2x. Now, from here, we need to simplify the right-hand side. So 2h all squared. Keep in mind that you square everything that is within the brackets. So the 2 will get squared and the h will get squared, leaving us with 4h squared plus 9h squared minus, now we're going to multiply 2 times 2h times 3h. So you can put the numerical values into your calculator. Negative 2 times 3, and that is going to give you negative 12. Now, for the variable part, all you need to do is multiply the variables. Because they have like bases, you're going to add the exponents. So that is then going to give you h squared, cos of 2x. Now, from here, you can see that you have like terms, which is 4h squared and 9h squared. Keep in mind that negative 12h squared cos 2x is not a like term to 4h squared, 9h squared. Even though all three of them have h squared, the negative 12 doesn't only have h squared. It also has cos of 2x attached to it. So it is not a like term to the highlighted terms. So let us add 4h squared and 9h squared, giving us 13h squared. Now, from here, let us go and have a look at what was the BC value that the question had and how is it different to our value, so we can try and see what direction we now need to move towards or move in. So we have BC equals h, the square root of 25 minus 24 cos squared x. So do you see that cos squared? That is cos squared, not cos 2x. We have cos 2x. How do we turn cos 2x into cos squared x? Now, if you noticed, cos 2x is a double angle. So let us now see what double angle formulas we know. So cos 2x is equal to cos squared x minus sine squared x, 1 minus 2 sine squared x, 2 cos squared x minus 1. So those are the three double angle formulas of cos that we are already familiar with. So which one are we going to use? If you remember, their value of BC only had cos in it. It didn't have sine. So we're not going to use anything that has sine in it. So we are going to use cos 2x equals 2 cos squared x minus 1, because that is the only identity that has cos only. So let us substitute. We have BC squared is equal to 13h squared minus 12h squared into 2 cos squared x minus 1. Now we need to multiply this negative 12h squared into our bracket. That is then going to give us BC squared equals 13h squared minus, so negative 12h squared times 2 cos squared x. So we multiply negative 12 times 2, that is going to be negative 24. We then multiply h squared and cos squared x, that is just h squared cos squared x. Next, we multiply negative 12h squared with negative 1. So negative 12 times negative 1 gives us positive 12 h squared. Now from there, you notice that you have like terms. So we're going to add up the like terms. So we have BC squared equals 13 plus 12 will give us 25h squared minus 24h squared cos squared x. Now we can see that we have a common factor of h squared. So we're going to take out that common factor of h squared and we'll be left with 25 minus 24 cos squared x. Now from here, in order for us to solve for BC, we need to square root BC. And if we square root the left, we know that we have to square root the right as well. So we're going to square root the whole of the right and the whole of the left. That is going to give us BC equals the square root of h squared into 25 minus 24 cos squared x. From there, we can simplify that. So we know the square root of h squared is just going to be h, and we cannot square root what's in the bracket, so the square root will remain for that part. Okay, so that is now our final answer. If you notice, we have BC equals h, the square root of 25 minus 24 cos squared x. And that is exactly what the question has. BC equals h, the square root of 25 minus 24 cos squared x. So we've done it. All we needed to do was use our cosine rule, whereby we substituted the values that are next to the angle and the angle itself into our formula in order to solve for BC in terms of h. Now, let us move on to the next question. So this question is from a November 2016 exam paper. So we have AB represents a vertical netball pole. Now keep in mind, any pole has to be built at a 90-degree angle to the ground. If that pole is not at a 90-degree angle to the ground, the pole is going to fall over. So that means that that pole AB is perpendicular to the ground. So we have AB represents a vertical netball pole. Two players are positioned on either side of the netball pole at D and E. So at D we have, let's say, player 1. And at E we have, let's say, player 2, because they're both positioned at either side of the netball pole. And this side AB, this is our netball pole. Okay. Such that D, B, and E are on the same straight line, which means D, B, and E form a straight line. So we can have a triangle ADB if we want to. We then have the points B, C, and D and E are on the same, so that includes C as well, so I missed that initially. So A, B, C, and D are all on the same line, which means we can assume that to be the ground. So D, B, C, and E are all points on the ground. The angles of elevation, so elevation is another word for inclination. So the angles of elevation from C to A and from E to A are X and Y respectively. The distance B to E is K. So from B to E is K. So we have B to E is equal to K. We then know that the angle E is Y and the angle C is X. So let us now look at our first question. So our question 7.1, write down the size of ABC. So let us identify ABC. So ABC, so this is our angle ABC. Now, if you remember what I previously mentioned is that B, D, E, and C are all points on the ground, which means that C is a point on the ground and AB is the netball pole, and any pole is always built perpendicular to the ground. So if we were to draw this, so we have A, B, and C. This is our ground, and this is our netball pole. Now keep in mind, any pole is always drawn perpendicular to the ground, which means that there's an angle of 90 degrees. Therefore, the angle ABC is going to be equal to 90 degrees. Let us now have a look at our next question, question 7.2. Show that AC is equal to K tan Y over sine X. So let us find side AC. So our side AC is from the top of the netball pole till that point C, and the angle of elevation of the side AC from point C is X degrees. So if we want to find the side AC, let us use the triangle ABC. So we'll start by drawing the triangle ABC. So we have B, C, and A. Keeping in mind this is 90 degrees. We need to find the side AC, and what is known? We do not have, oh, we know that this is X. So how can we now use this to find the side AC, as we do not have many values? So let us see. Another thing that we can see is the side AB is a common point between the triangles ABC and ABE. So let us now draw triangle ABE and see how can we use both triangles. Because if you notice, our answer for AC has both Y and X in it. So that's an indication that we are meant to use both triangles, ABC and ABE. So let us now draw ABE. So those are our triangles ABC, which has an angle of inclination X at point C, and we have ABE, which has length BE as K, and it has an angle of inclination at point E of Y. Now, let us look at our question. Show that AC is equal to K tan Y over sine X. So if you look at our question, it has K tan Y. So if we are using Y as our reference point, let us now use tan, because our numerator in our question has tan Y. So let us now go and find tan Y. So if we want to use tan, we need the opposite. and we need the adjacent. So tan of y is equal to the opposite, which is AB, over the adjacent, which is k. From there, we can cross multiply and solve for AB, and we will end up with AB equals k tan of y. Now that is our value of AB. Now, let us have a look at our question. So as you can see, we've already found our numerator of our answer. We found AB as k times tan y. So we found part of our solution. Let us now try and find the denominator and see how we can incorporate AC into this. Now, if you look at your denominator, it is sine of x. So let us now find sine x. So if you notice, we're not really doing that much work. All we are doing is looking at the solution in the question and try to match it up. We are using the question as a guide. So if we want to find sine of x, we are going to use the opposite, which is AB, and the hypotenuse, which is AC. So that is then going to be sine of x equals our opposite, which is AB over AC, which is what we are trying to find. Now, let us try and solve for AC, or to isolate AC. So that is going to be AC equals AB over sine x. So those are our two equations. Now, if you notice, we have AC equals AB over sine x. So all we are now going to do is, in place of AB in our second equation, we are going to substitute k tan y. So let us bring this down so that we can start the substitution process. So we are now going to substitute k tan y in place of AB. So that is then going to be AC equals k times tan of y all over sine x. And that is exactly what we are looking for. We don't have to think that much. All we needed to do was look at the question, and that guided us on what we needed to do. So that is our answer to question 7.2. All we did was find sine x of our first triangle ABC and find tan y of our second triangle ABE. We then combine the two equations to solve for AC. Our next question is question 7.3. If it is further given that DAC is equal to 2x. So let us find DAC. So the angle DAC is this angle over here. If it is given that that angle is equal to 2x and AD is equal to AC. So AD, which is this side, is equal to AC, which is this side. That means this is now an isosceles triangle because it has two equal sides, therefore it'll have two equal angles. Show that the distance DC between the players at D and C is 2k tan y. So let us go back. They said the players are D and C. Let us read this quickly. A third player is positioned at C. Okay, so we have player 3 that is positioned at C. So this is going to be player 3. So we were now told that the angle DAC is 2x and AD is equal to AC, and we need to show that DC is equal to 2k tan y. So let us now connect the side DC so that we have a full triangle. So that is now our side DC that was constructed in that purple line. So we have our triangle ADC, and we need to find what is the value of DC, or rather we need to show that the value of DC is 2k tan y. So let us start by drawing our triangle ADC, putting in the known values, and then solving for DC. So this is now our triangle ADC, keeping in mind that we've previously calculated AC as k times tan y all over sine x. Now, because it's mentioned that AC is equal to AD, that means AD is also going to be k times tan y all over sine x. Now, we need to find DC. So if you notice, we have an angle, which is angle A, and two sides adjacent to that angle, or two sides on the side of that angle. So that is an indication of our cosine rule, because we are now trying to find the angle, because we are now trying to find the side opposite that angle. So if we are trying to find DC, we're going to look for the angle opposite DC, which is angle A of 2x. From there, we can arc this, put in our arrows, and that tells us, or we are now receiving confirmation that we are going to use the sides AD and DC. So let us start by putting in our cosine formula, which is now going to be DC squared equals the two sides on the side of the angle, which is AD squared plus AC squared minus 2 times AD times AC times cos of angle A. If I were to substitute k times tan y all over sine x into this equation, it's going to be quite complicated. I'm going to try and simplify this while it is in this current form. So what do we know? We know that AD is equal to AC. That is important. We were told that. So in place of AD, I'm going to substitute AC. So this is then going to become DC squared equals AC squared plus AC squared minus 2 times AC times cos of A. Now, from there, as you can see, we've got AC squared plus AC squared. So that is going to give us 2AC squared, because we're adding up like terms. Whenever we add up like terms, we just add up the coefficients in front of those like terms and then place in our variable afterwards. Minus, now we have AC times AC, so that is going to give us AC squared. Cos of 2 2x. So I'm going to substitute the 2x only. Now from here, you notice that you have a common factor, which is 2ac. So let us factor that out. Let us actually factor out 2ac squared. And we'll be left with 1 minus cos 2x. So let us go back to our initial question and see what our DC value was supposed to be. So it states, show that the distance DC between the players at D and C is 2k tan y. So our value of DC needs to be 2k tan y. So let us go back and try and simplify. Before we substitute, let us do one more thing. Let us now square root both sides. So once we square root both sides, we're going to end up with the square root of 2ac squared into 1 minus cos 2x. The reason I want to square root is because I want to try and turn that ac squared into only ac. So if I were to square root the ac squared, I'd be left with ac, the square root of 2 into 1 minus cos of 2x. So let us now substitute our value of ac. So we know our value of ac is k tan y all over sine x. So that is going to be dc equals k times tan of y all over sine x times the square root of 2 into 1 minus cos 2x. Now from here, let us go back and look at what was our value of DC supposed to be, so we can have a sort of guide on what we need to do. So our value of DC is 2k tan y. So let us write that down so we don't forget. So DC is supposed to be 2k tan of y. That is supposed to be our value of DC. Now, if you notice, there is no sine or cos in that answer of DC. So what we now need to do is we need to get rid of cos and we need to get rid of sine. So if you notice, sine is a denominator and cos is a numerator. So we need to somehow get a sine on top in the numerator section. We need to turn cos into sine so that it can cancel out with the sine x at the bottom. So let us see, how can we do that? We know that cos 2x is equal to cos squared x minus sine squared x. We know that it's also equal to 1 minus 2 sine squared x, and finally 2 cos squared x minus 1. So which one are we going to use? If we want to turn the cos into sine in order to cancel out with the sine at the bottom, let us choose the one that only has sine in it, which is our second identity. So I'm going to substitute in place of that cos 2x, I'm going to now substitute 1 minus 2 sine squared x. So let me replace that rounded bracket with a squared bracket and then introduce 1 minus 2 sine squared x. So the reason I used a square bracket and a rounded bracket is because I wanted to show that I now need to multiply this negative sign into my rounded bracket in case I forget, because it is easy to forget that that negative sign in front needs to be multiplied across everything within. So it makes it easier to put it in brackets. So I bring down my DC equals K times tan of Y all over sine X times 2 into, now this is going to be 1 minus, so negative 1 times positive 1 is negative 1. Negative times negative 2 sine squared x is going to be positive 2 sine squared x. From here, I can simplify what's in the bracket. So that then gives me DC equals K times tan of Y all over sine X times 2 into 2 sine squared x. From here, I can multiply 2 times 2, and that is then going to give me 4. So that is then going to be 4 sine squared of x. Now, if you notice, we have 4, which is a squared number, and we have sine squared of x, which is also a squared number. So we are going to square root that. So that is going to be square root of 4, that gives us 2. Square root of sine squared x, that gives us sine x. Now, if you notice, we have sine x cancels sine x, and we can therefore be left with k times tan y times 2. So we can multiply this and finally have DC equals 2k tan of y. And let us go and see if that is what we wanted. Yes, that is correct. We wanted DC as 2k tan y.